Identifying polynomial functions in the leading coefficient test. Determine whether the function is a polynomial function. If it is, identify the degree. In order to determine if we have a polynomial function, we want to look at each term in the polynomial. Our first criteria is that all of the coefficients in front of the variables must be real numbers. So we can't have any imaginary numbers or numbers with I in them, or square roots of negative numbers. So if we look at each coefficient, we have 5, we have pi, and we have 1/6. So each of those numbers are real numbers. So it fits that criteria. The second criteria is that we must have non-negative whole numbers as our exponents. So if we look at each of our exponents, we want to make sure that they are not negative or fractional exponents. So we have a 5, a 4, and a 2, and all of those exponents are non-negative whole numbers, so it fits that criteria. Therefore, I can say that I do have a polynomial function, and now I want to know what the degree of the polynomial function is. So the degree is the highest exponent, or the largest exponent. So between 5, 4, and 2, the largest value is 5. So the degree of my polynomial is 5. Is the graph on the right the graph of a polynomial function? In order to determine if this graph represents a polynomial function, it must be smooth and continuous. So first we'll check to see if it is smooth. This is our first criterion. A graph is smooth if it contains only rounded curves with no sharp corners. If we look at this graph, we can see that we only have rounded corners or curves. We do not have any sharp corners, like this would be a sharp corner. All of those would be sharp corners. Since we don't have that in our graph, then yes, our graph is smooth. So that criterion is true. Now we have to see if the graph is continuous. This is the second criterion to make sure that our graph represents a polynomial function. A continuous graph means that the graph has no breaks and can be drawn without lifting your pencil from the coordinate system. So if we start tracing this graph, I'll start on the left side and trace this portion of the graph. But if you'll notice, I have to pick up my pen in order to trace the other section of the graph. That's because this graph has breaks in the graph. It's not continuous. So this graph does not meet the second criterion. That means that this graph is not a polynomial function. Use the leading coefficient test to determine the end behavior of the graph of the given polynomial function. We have negative 4x to the fourth plus 3x squared minus x plus 7. In order to use the leading coefficient test, we first want to list the leading term. So the leading term is the term that has the highest exponent. So that's going to be negative 4x to the fourth. Next, we'll list the degree of the polynomial, And again, the degree is the highest exponent, so that would be 4. And then we want to list the leading coefficient. So that's the number in front of the x value of the leading term. So the leading coefficient is a -4. Now, if we look at the degree, our degree is even. And if we look at our coefficient, our leading coefficient is negative. So we're going to use these two characteristics to identify what our end behavior will look like. And here I listed a chart, and we're going to use this chart to tell what the end behavior looks like. Now it says, it lists n and a sub n. Now n is going to be the degree, and a sub n is the leading coefficient. So we're looking for an even degree and a negative leading coefficient. So here I have for n is even and a sub n is less than 0. Then we have an end behavior of the graph falls to the left and falls to the right. So since I do have an even degree and my leading coefficient is less than 0, then I know that my graph falls to the left and falls to the right. So this is my answer, and that is called my end behavior.